Many manufacturers are operating in a new reality. Legacy machines have been activated with smart sensors, finally connecting the production floor to the digital world. But that connectivity creates a massive volume of information. A single sensor recording every second generates over 86,000 data points a day. With 100 sensors, a factory produces 8.6 million individual records every 24 hours. Confronted with this influx, many SME owners instinctively invest in physical infrastructure. They spend significant capital on large, on-site server racks to store the rising tide of numbers. Collecting millions of raw data points without a specific analytical goal is data hoarding. Without a plan to process and interpret them, these databases become little more than digital waste. Injection, a plastic molding factory. They faced a costly, recurring problem: unpredictable sink mark defects on their finished car parts. The defect rate fluctuated between 3 and 5%. This seemingly small margin wasted hundreds of thousands of baht in discarded materials every single month. The engineering team spent months manually adjusting machine pressure and furnace temperatures, yet the defects continued to appear at random intervals. Human logic and standard spreadsheets cannot keep up with this many variables. The mathematical weight of millions of data points, tracking heat, pressure, and speed simultaneously, is too complex for manual troubleshooting. To find the root cause, the factory had to move beyond manual analysis and adopt a system capable of interrogating every variable at once. Solving these types of production anomalies requires a different type of investigative architecture. Factories are solving this processing bottleneck by migrating their entire data infrastructure to the cloud. This shift changes the financial model of the factory. Instead of large upfront capital investments in physical servers, companies rent computing power on a flexible, monthly basis, paying only for the capacity they use. Cloud systems also offer superior protection. A server kept in a factory closet is vulnerable to hardware failure and local security breaches, while global cloud providers use high-level encryption and AI-monitored defense protocols to protect data 24/7. Capacity can also be expanded instantly. Moving from 10 sensors to 1,000 no longer requires new wiring or hardware. It only takes a few clicks to provision more power. Because the data is hosted remotely, management can access real-time production dashboards from any location with a fast internet connection. This accessibility levels the playing field, allowing a small SME to harness the same massive computing clusters used by global conglomerates. To solve the mystery at Siam Injection, the team moved 1 month of historical telemetry, over 2 million records, into a cloud-based data lake. They merged the machine's internal data, like injection speed, with external environmental sensors tracking the humidity and temperature inside the building. The cloud system scans through disparate streams, searching for correlations, where multiple variables align to cause a failure. The analysis revealed a hidden intersection. Defects occurred only when humidity rose above 70. The factory implemented a new automated rule. Whenever the sensors detect a spike in humidity, the system automatically raises the cooling water temperature to keep the process stable. The results were immediate. The defect rate fell from 5% to just 0.1%, stopping the monthly financial drain. This case highlights a core principle of Industry 4.0. Raw sensor data is like crude oil. It is potentially valuable, but it cannot power an engine in its unrefined state. For that data to become fuel, it must pass through a refinery. Cloud computing acts as that refinery, turning a chaotic swarm of numbers into actionable insight. Companies that cling to on-premise hardware risk being overwhelmed by their own unrefined data while remaining vulnerable to equipment failure. Migrating to the cloud today provides the necessary foundation for implementing more advanced tools, such as predictive maintenance and AI-driven machine vision. In Industry 4.0, long-term profitability depends on the ability to turn raw data into a refined, actionable resource.